Yes, we are continuing with our tutorial. Still on question 1. You are asked to find the indefinite integral of this integral. Yes, so let's just dive in. Let me pick my pen. So yes, so maybe to rewrite the question as usual, pick the black pen. So the question was, if I still recall well, it was cosec squared x over cot x, and in the bracket you have 2 plus 3 cosec x. Yes, then yeah, there, the integral dx. Yes, so you just have to find the indefinite integral. So I think maybe the identity that we're going to use here, remember this is an identity you should know. Remember that cosec x squared is equals to 1 plus cot tangent squared x. This is from cosec squared x minus cotangent squared x is equals to 1. So I just made this subject of the formula so that I can replace it here. Yeah, so let me rewrite my question. So maybe just to rewrite this one so that I simplify it. So if I replace cosec squared x with 1 plus cotangent squared x, that means I will have something like 2 plus 3 multiplying 1 plus cotangent squared x. Yes, and then distributing that, I'll be having, distributing this 3, I'll be having 2 plus 3, that will make it 5 plus 3 cotangent squared x. So then maybe just to add this will be 5 plus 3 cotangent x, no, just single t x squared. Yes, so I will be replacing this with everything here. Yes, so maybe just to rewrite our question with our black marker, I'll be having cotangent x, and then everything else, that's 5 plus 3 cotangent squared x, and then remember we have cosec x here, cosec squared I meant, and then dx. So yes, I can see that our question is for me. Then from here, I think if you see, you can go ahead and perform u substitution. Yeah, you're going to let your u, from here you can see that you can let your u be cot x, because you know that the differentiation of cot x is simply negative cosec squared x, and then that will take out this. So go ahead, u is equals to cotangent x, so that means du is equals to negative cosec. By the way, you should know this, then I was differentiating dx, and then you know that when you are doing your substitution, you have to make dx subject to the formula. Then from here I can see that dx will simply be negative du over cosec squared x. So now, so that means from here I have to replace u with u, and then dx with whatever dx is, and then I can see that I will be having this type of question. Let me pick maybe a green mark. Yes, I'm just rewriting the question. So at the top I still have cosec x, and then remember my u as cot x, so I will be having u here, then 5 minus 3 u squared, and then remember I said that dx is equals to negative du over cosec squared x. Yes, this is how to do u substitution. So what I just did here, I just replaced u with u, then dx with whatever dx is, and then from here you can see that this will cancel out, cosec squared will cancel out, and then you will remain with, and then you know that when you have a constant like negative 1 here, you can take it in front of the integral sign, and then you'll be having something like 1 over u 5 minus 3u squared, then du. Yeah, and then when you have something like this, by the way, I think there are many ways of doing this question. This is just my preferred method. So also I will repeat again, if you have any simpler method that you already understand on how to approach this question, you don't have to follow mine. This one is for those who doesn't know their left from their right on this particular question. So yeah, so let's dive in. So from here, I think I have to integrate by parts here, by parts. So if I have to integrate by parts, that means I have to rewrite this fraction into its parts. So that will be 1. I'm just copying that question. 5 minus 3u squared. This will be a over u, and then plus. One thing we have to notice that you have a quadratic factor here. So if you have a quadratic factor, remember you write bu plus c over 5 minus 3u squared. Perfect. Then from here you have to solve for your constants a and b and c. Yeah, so the first thing is that you have to multiply by this, everything. So if you multiply everything by this, that means this term will cancel, and then here this will cancel, and then you will remain with this term. And then for now, if you multiply, this term will cancel, then you're left with u. So to rewrite this question, we pick a black mark. I'll be having 1 is equals to a, then I'll be left with 5 minus 3u squared, then plus bu plus c, then multiplied by u. I think maybe to just distribute here, distribute the a here of this would be 1 is equals to 5a minus 3a u squared. Yes, then moving on, distributing this u, you'll be having b u squared plus c u. Yeah, then from here, you know that when we are applying by parts, you just have to, here you can't pick a strategic value because it won't help you. So that means I'm going to equate the coefficients. So that means if you take the term of the u squared, I simply have something like 3a, negative 3a plus b, that is equals to 0, because I don't have anything squared on my left hand side. And then you can see that c also is equals to 0. Yes, c is equals to 0. Then you can see that 5a is equals to 1. And then if 5a is equals to 1, solving for a will simply be 1 over 5. Then taking this 1 over 5 into here, you can simply find b. Yes. By the way, where did I get the negative 5 minus? No, you made a mistake. This is 5 plus, so my bad. Yes. So this will be positive here. This will be positive here. Yes, I'm just correcting that. I made a mistake. You can see that from here. After simplifying, we found that 5 plus 3/4 x. So there's no how I ended up with this negative. Yes, here also it's plus. Then it's plus. Yes, perfect. That was just a mistake. Please don't do this in your exam. So even here it's positive. So that means we found that a is equals to 5. That means taking this 1 over 5 into here, I can solve for b. That means isolating b here. B will simply be negative 3 over 5. How did I find this? You substitute 1 over 5, and then that will be 3 times 1 over 5, which is simply 3 over 5. Then I take it to the right hand side. It becomes negative. So b is equals to negative 5, and then c is equals to 0. Now that means I have to replace my constants with these guys. You get? So that means if I say that a is equals to 1 over 5, that means I have something like 1 over 5 over u. That's plus b. What's our b? Our b is negative 3 over 5, remember. So that means it's negative 3 over 5, right? And then remember you had u here. you had u, then c is equals to 0, so don't mind c. Then here you have 5 plus 3u squared. So we have to replace your integral with this. So your integral, remember you have -1 outside, remember that. Yes, so now if you are here, I think maybe I can rewrite this in a simpler form. This, so 1 over 5, it will be simply negative the integral of 1 over 5u. Then that's negative. Then maybe, or let me take 3 over 5 out also. Let me just take 3 over 5 out. And then I'll be left with u over 5 plus 3u squared. Only put du here. And also I need du here. Yes, I think from here, and then remember that this negative applies to everything that's inside here. So I think from here you can integrate, because from here, this part of the equation, I can see that I can integrate because I know the integral of 1 over u, because I can simply take 1 over 5 outside. So, but then our worry now is only this part of the equation. So if you look at this question, this part, I'm going to rewrite this part alone. Yes, so I have 3 over 5 outside. Then inside the integral, I simply have I have negative, I still have negative here, and then I have u over 5 plus 3u squared du. How can you integrate this? How can you integrate this type of question? I think we are still going to apply u substitution. So that means u substitution. Let my v be equals to 5 plus 3u squared. Then dv will simply first the derivative of this, right? Which is simply 3 times 2, that's 6u du. So making du substitute the formula, that means du will simply be dv over 6u. So now, since I'm using u substitution, I have to replace u with u, then du with du. So from here I can see that I can simply write, I'm going to rewrite, this doesn't change. So at the top I still have u, and then 5 plus that's 3. Oh no, that's 5 plus v, because I said this thing is v. Then the integral du, I have to put du. Now remember that I say du is dv over 6u, so it's dv over 6u. And then from here, there's multiplication here. And then this will cancel this u. And then you'll be left with, then you can see that there's still a 6 here, so it will be 6v. So we'll be having something like 1 over 6v dv. So you can integrate this, because I can integrate this. How can I integrate this? That will be 1 over 6, the integral of 1 over v dv. You understand? And then I know that the integral of this, and then this 1 over 6, I don't have to mind it. I just put it 1 over 6, and then multiply by the integral of 1 over v is natural log, then absolute value v plus c, right? And then I know I have to replace v with v before I can continue any further. So if I have to continue any further, remember we say that our v is equals to 5 plus 3u squared here. So that means 1 over 6 natural log absolute value of 5 plus 3u squared, then absolute value plus c. So, and then also remember that you cannot leave this in terms of u. So also remember that we said that our u, when we started, our u was what? Our u was cotangent x. So if our u is cotangent x, that means you have to replace u with cotangent x. So that means if I have to rewrite that part of the equation, I have 1 over 6 natural log 5 plus 3 cotangent squared x. Oh, come on. 3 cotangent. Oh, I'm running out of space here. 3 cotangent x, right? Then put the absolute value. That's it. Now remember that this part of the question is simply this. So that means I still have negative 3 over 5 here. So let me rewrite how far we have went, just in a nutshell. And then, okay, then we're just going to write the whole question. I had negative outside. And then I had the integral of 5, 1 over u. We didn't apply that one. Then I have negative, then I have minus 3 over 5 multiplied by the integral of what we found, which is simply 1 over 6 ln absolute value 5 plus 3 cot square x, right? So I cannot put the constant of integration because I haven't integrated this part of the equation, this one. So also this one is very simple, that's why I didn't mind it. So maybe let me distribute this negative 1 over 5. So if I distribute the negative 1 over 5, you know the integral of 1 over u is simply ln absolute value inside u. So that means if I distribute the negative, that will be negative 1 over 5 multiplied by ln absolute value u. And then remember that we agreed that u is equals to cot x. So let me go ahead and replace u with cot x so that we clean up cot x. Now if I distribute this negative here, that means negative 3 over 5 will become positive. And then also I can maybe multiply 3 over 5 multiplied by this 1 over 6, like multiply this. So it will be positive 3 over 5 multiplied by 1 over 6, which is 5 times 6, that's 30, and 3 over 30, that's 1 over 10. So that's 1 over 10, and then ln absolute value of 5 plus 3 cot squared x, close, then constant of integration. So I know it's a bit sketchy, but I'm doing these questions for understanding purposes. Yes, not for aesthetic purposes. I hope that sink into your head. So this is the final answer. So once again, this type of question will always come out. And if you notice, the trick around these questions are simply identities and to know how to use them. So see you on the next question.